From time immemorial, man has been fascinated by structures. Structures that floated in his dreams and imagination. Patterns that he saw around him. Those that he stared in awestruck wonder when he looked at formations shaped by the forces of nature over the millennia. This fascination inspired him to journey the path of exciting discoveries and challenging innovations, resulting in aesthetic, complex, efficient, yet safe structural forms. Thus, planet Earth was destined to bear on its surface structures that were engineered to perfection. The Indus Valley, Sumeria, Babylon, Egypt, Greece, Rome, China, a few of the many places on planet Earth that have given us some of the most magnificent structures. And today, we have breathtaking structures to showcase as a human race that has excelled through this great evolution of thought.
The Council of Scientific and Industrial Research, established by the Government of India in 1942, is an autonomous body that has emerged as the largest research and development organization in the country. It is a network of 38 laboratories and 39 field stations or extension centers throughout the nation. CSIR-Structural Engineering Research Center, Chennai, established on 10th June 1965, is one of the national laboratories under CSIR. The center is recognized at the national and international level as a leading research institution in the field of structural engineering. The vision of CSIR-SERC is to be a global leader in structural engineering by excelling in research in frontier and cutting-edge areas and by developing competitive technologies by embracing innovative inter- and transdisciplinary approaches for the benefit of the society and industry. The Charter of CSIR-SERC envisages the center to act as a clearinghouse for latest knowledge and expertise, undertake application-oriented research, and provide design consultancy for complicated and novel structures which could not normally be done in regular consultancy offices, and undertake sponsored research and organize advanced courses for the benefit of practicing engineers in the broad area of structural engineering. The mission of CSIR-SERC is to pursue and excel in research in frontier and cutting-edge areas of structural engineering and to create niche areas. To emerge as the most preferred research source center for industry for solving new challenges in structures of different size, shapes, geometry, and purpose of use. To develop and transfer suitable technologies addressing societal needs, to be a preferred knowledge center for providing structural engineering solutions for pre- and post-disaster needs. CSIR-SERC over the past 5 decades of its existence has undertaken all the above activities and has excelled in most of its pursuits. It has provided high quality R&D and S&T to the industry. There have been many landmark achievements and many laurels to its credit. To name a few, high strength deform bars aiming at import substitution, pre-stressed railway sleepers towards green solution. Towards strategic structure, CSIR-SERC has contributed significantly where design of pen structures, mobile launch pad design to layered reinforced storage structures. Presently, India is expanding its infrastructure very fast and consequently the demands of contribution of CSIR-SERC have increased manifold.
CSIR Structural Engineering Research Center, a constituent laboratory of the Council of Scientific and Industrial Research, Government of India, salutes this undying spirit in mankind. Born from a chrysalis of inspiration in the year 1965, SERC is today a full-blown center for excellence in the Chennai metropolis, southern India. From small beginnings, this center has grown to become a colossus in structural engineering research and consultative expertise, touching the lives of people in India and across the globe. It has indeed been a long and memorable saga of dedicated and tireless contributions by many, starting from the first director of the center, Professor G.S. Ramaswamy, to the successive directors and leaders of this center. Set in a verdant landscape, the SERC campus sprawls over 65 acres to house several of its research laboratories that facilitate critical socio-economic leverage to impact and extend large-scale beneficial changes. At the core of excellence in SERC is its team of brilliant scientists and erudite scholars who have, over the years, shaped the center to what it is today.
CSIR-SERC has identified a number of thrust areas for in-house R&D and has created excellent infrastructure for the same through generous government grants, UNDP assistance and external cash flow realized through its own activities. CSIR-SERC has developed a number of technologies which were for the benefit of the society and also which were transferred to several private and public sector organizations. CSIR-Structural Engineering Research Center has been focusing its R&D programs in the following broad thrust areas: structural health monitoring and life extension, disaster mitigation, advanced materials for sustainable structures, special and multifunctional structures. CSIR-SERC has built world-class facilities and expertise for analysis, design and testing of structures and structural components which are being continually updated to keep them as the state of the art. The R&D laboratories of CSIR-SERC are created with a purpose and is towards every aspect of structural engineering. Analysis and design is an important area and understanding the science behind the behavior essential to build safe structures. Theoretical and computational mechanics laboratory is created with this purpose. Understanding material behavior is the next step. This will help to develop new materials. We have advanced materials laboratories and steel structures laboratories. Load assessment is critical in arriving at economical as well as safe structures. Advanced seismic testing and research laboratory, fatigue and fracture laboratory, wind engineering laboratory work towards this. After construction and erection of structures, it is essential to maintain them as well as assess their life or health throughout their life. To address these, structural health monitoring laboratory, advanced concrete testing and evaluation laboratory were created. Studies to achieve simultaneous improvement in multiple structural functions are carried out at Special and Multifunctional Structures Laboratory. Transmission towers are the most vital component of power transmission system. Unique facility for full-scale testing is available at our Tower Testing and Research Station. Research and development efforts at CSIR-SERC deal with the development of improved analysis, design and construction techniques for different types of complex structures such as shell roofs, transmission line and microwave structures and other tower-like structures, ships, offshore structures and machine foundations. Over the years, several general purpose computer software packages have been developed for computer-aided analysis, design and drafting of various structure and structural components. The center has also been publishing the Journal of Structural Engineering since 1973 to participate, promote and disseminate research in structural engineering. Many organizations have been benefited by availing the services of CSIR Structural Engineering Research Center. The beneficiary includes central and state governments, public and private sector undertakings and international clientele. Scientists of CSIR-SERC serve on many national and international committees, professional bodies, editorial boards and as reviewers.
The Advanced Concrete Testing and Evaluation Laboratory. ACTEL has, over the years, developed expertise in non-destructive testing and evaluation for quality control and condition assessment of concrete and masonry structures.
This is one of the oldest divisions of CSIR-SERC, and for the past 2 to 3 decades, importance has been given for the condition assessment of concrete structures, mostly reinforced concrete structures as well as pre-stressed concrete structures.
Durability studies are conducted on various types and grades of concretes made using mineral and chemical admixtures so as to evaluate their influence on the service life of concrete structures. It is of little wonder that SERC has succeeded in enabling the construction industry to put up cost-effective structures like they have done in their campus. The lightweight EPS model building that can be either a residential or an office space. Model beacon tower such as this one. Water tanks built with an innovative symmetry, saving space and costs. Ferro cement service core units, fiber reinforced concrete manhole covers.
This is Advanced Materials Laboratory, which is carrying out research and R&D activities in the area of construction materials. At present, we are working at alternate binders and aggregate systems, which is required for the sustainable development of the infrastructures.
Scientists of this laboratory have developed newer construction materials such as ultra-high strength fiber reinforced concrete, high volume fly ash concrete, lightweight concrete, fiber reinforced concrete, geopolymer concrete, foam concrete and self-compacting concrete. R&D is also being carried out for new repair materials and techniques. The Advanced Seismic Testing and Research Facility, popularly known as the ASTAR Lab, features shake table and pseudodynamic test facilities, the largest in the country.
In this lab, we try to evaluate the response of structures subjected to earthquake loading. These models of the structures are fixed rigidly to the equipment called as shake table, and the real earthquake will be applied. Then the response of the structure is going to tell whether the structure is safe or any design improvement has to be made on the structure. Many experiments are done in this lab, and some of the experiments are unique and done for the first time in South Asia.
The Fatigue and Fracture Laboratory, FFL, features state-of-the-art infrastructure and expertise to study the behavior of structural components and materials when subjected to repetitive loads.
This laboratory was started in 1989, and that time was called the Fatigue Testing Laboratory. The so-called Fatigue Group was started in CSIR-SERC in July 1983. The facilities we have can be ranked as one of the best globally for experimental investigations on structural components and materials. Our activities include in-house research and development projects and externally funded projects for the industry in terms of consultancy and sponsored research projects.
Fracture studies under monotonic loading are carried out on weld joints of bimetallic pipes. to study the crack growth behavior and failure pattern.
Basal and Multifunctional Structures Laboratory of CSIR-SERC has the unique expertise on doing the research work from the nano or the atomistic scale to the macro or the mega scale structures. In this group that we are working from the atomistic modeling by the MD solution, but then we are doing the nanomechanics, micromechanics, and then we go forward to develop the methodologies for the structures and to have the performance of those structures. Now, this group is involved intensely to doing the analytical, numerical, and also the experimental works at different scales. Basically, and the interdisciplinary group, so which takes care of the manifold of the structures, mechanics, and the sensors. So here that we are using the acoustic emission technique, by which we are also seeing a test by using the corrosion test, so which will be a critical thing for almost all failures for the civil engineering structures. So this type of corrosion, how it is getting initiated and getting propagated, if you are not able to see from outside, how we can capture successfully and appropriately, so by using the acoustic emission testing that is being carried out in this group. So here also we are trying to see that how we can employ the ultrasonic technique in a proper way. But here we are using the advanced ultrasonic by using the nonlinear features from those ultrasonic signals, and we are trying to see that those features, whether it can extend the incipient damage, it is being occurred inside the structure. So it is a very high sensitive, low capacity UTM, which is having the maximum capacity of a 2.5 ton, and it is a fully fatigue rated. This research group is also working to use the state-of-the-art facility by using the laser vibrometer, by which we can develop the strategies for having a non-contact SHM of structures. So here we will be having two different heads, so where we can give for the low frequency and the high frequency, and high frequency it can go up to 1 megahertz, so that by which in a non-contact way also we can try to understand and to also assess the structural integrity. This is the environmentally controlled nano and micro indentation facility, where the nano and micro heads have been mounted into the same heads, and we can investigate and experiment the behavior and the properties of different type of material at a very low scale. And by the name of the heads of the nano and micro, that shows that we can try to understand the behavior of the material at the nano micro scale. And here the special interest for the civil engineers are that because of the cement based material, the building block is the CSH gel, which is of the nano size, and when it will be getting to scaling up, it will be giving you a micro size properties. So the evaluation of those properties during the hydration process under different environmental conditions, it will be giving you the new area or the new understanding of the subject, that to develop, design, and to improve the properties of the material accordingly.
A warm welcome to Steel Structures Research Facility. The team of scientists here basically work on analysis, design and testing of steel structural components and structures. For the first time in the country, we have recently conducted shake table experiments on a scale model of a G+7 multi-storied steel frame building, based on which a prototype 10-storied building was constructed in a record break time of 48 hours at Mohali, Chandigarh.
The team of scientists at Steel Structures Research Facility of CSIR-SERC provides innovative solutions to steel manufacturers, power plant and infrastructure industries towards condition assessment, analysis, design and testing of their steel structures and components.
Welcome to Structural Health Monitoring Laboratory. The Structural Health Monitoring Laboratory, earlier known as Experimental Mechanics Laboratory in SCRC, is one of the earliest lab established here.
In CSIR-SERC, we have conducted extensive lab level as well as field investigations in order to investigate various structural health monitoring techniques. We use the techniques based on modes, model analysis, operational model analysis, experimental model analysis, time frequency analysis, time series analysis and multivariate analysis. All these techniques have been extensively used in our numerical investigations and the packages developed in around for structural health monitoring.
Our laboratory was established about more than 2 decades back. We are working on structures which are subject to suddenly applied loads. For example, during a blast we see the load will be very of high magnitude, and that has to be, the special structure will be acting in a special way which we have to address.
Field trials as well as advanced computational tools that run on dedicated, customized software platforms are relied upon to achieve this objective. Recently, efforts are being made to evolve international standards for risk analysis and risk management of structures. The finite element package, fine art, developed at the center, is being used to provide solutions to many complex engineering problems. The Tower Testing and Research Station, TTRS, state-of-the-art tower testing facility of CSIR-SERC, situated in Thirusulam, opposite the Chennai International Air Terminal, was established in the year 1984.
Towers and tower-like structures are pillars of our country for transmission of powers and telecommunication. In this regard, safe and reliable structures has been designed by SERC, in particular Tower Testing Research Station. This facility has the capability of testing the towers up to 80-meter height and a base width of 22.5 meter, and also have 3-dimensional loading system. In all the 3 orthogonal directions, it can apply the load up to 1200 tons.
Public safety, continuity of service, environmental impact and revenue stability all rely on the reliability of the transmission and communication tower design.
India has a long coastline of more than 7,500 kilometers and is prone to annual frequency of 3 to 4 cyclones. Since its establishment of boundary layer wind tunnel facility, we have been conducting miniature models of many buildings and structures, scaled down to a level of from 1:50 to 1:500. We have a mobile van lab which can be taken to wind energy farm, and then we make the measurement at the foundation of wind turbine supporting towers. Apart from the wind tunnel activities, we have designed one cyclone shelter for societal purpose, and 23 such cyclone shelters have been constructed along the coast of Orissa, which has withstood Super Cyclone 1999 as well as the Phylline Cyclone in the year 2013.
By deploying computational fluid dynamics, scientists of the Wind Engineering Laboratory have conducted R&D studies, while also contributing to many Indian standards related to wind loads. The CSIR-800 Program reveals SERC's true societal dimension.
CSIR-800 Program is for 800 million underprivileged people we are doing affordable housing technologies for these people. We have developed some technologies which can be easily adopted by the people. For example, we are using sustainable materials such as coconut shells, PET bottles, plastic waste to make lightweight wall panels.
The labs apart, SERC has a world-class knowledge resource division, truly a place to be, where the horizons of one's knowledge seek to transcend beyond the mere mortal intellect. SERC has a state-of-the-art 3-tier data center which caters to the ICT requirements of the center. SERC conducts periodic interactions with the industry to fully realize its dream of translating this expertise into real-world benefits. Such events happen at the magnificent Vigyan Auditorium, the pride of the SERC campus. The next time around, when we cross a bridge or take the metro or look up at the wonder of a high-rise, let us remember that SERC is right there by our side, firmly behind us and walking with us all the way, leading us all to a glorious tomorrow.